Let's get settled for one look into generative AI. There are many ways to approach the topic. Securing it, let's just say we're all kind of figuring that out pretty much as we go along. Technology and the solutions is developing as we do these tests and fail and end up in the press, and you know, the usual story. I'm a machine learning engineer at Solita, which is a Northern European, started in Finland, consultancy. We do a lot of things. We try to bring value out of data in a connected world. I've been there about 1.5 years now. My background is fairly common with machine learning people. So my background is in research and working with data. So I have played with data and tried to make sense of data for quite a long time. I started getting into machine learning about 5 or 6 years ago. So I'm fairly new. And in the security area, even newer. So 1.5 years, pretty much the time I started in Solita. First idea was, the reason I started transitioning into this field was because I started seeing the big headlines of about the compass and biases and all these quite public problems. Like, how many of you remember the Tay bot by Microsoft in 2016? Yeah. And in 2016, we started seeing a lot of fairly public issues. You had the Apple credit card and all these sorts of things. So I started getting interesting. I'm raising 2 kids. And I saw that this is going to be fairly big. I was luckily correct, because otherwise a lot of time and effort and some money would have been gone wasted by transitioning into the field. And so I started with that. How do we do trustworthy AI? And it's a fairly big thing. So I had to narrow it down, and in the years I've narrowed it from looking at the machine learning ops and then to the safe and secure machine learning. At Solita, I've built, with my colleagues, of course, an assessment framework looking at the culture of what's the maturity of companies with machine learning and operations, and then also building the threat matrix and how to mitigate, again, with colleagues. This will be a repeated pattern that machine learning is we're not unicorns. We don't want to be unicorns. It's a team sport. And then I have Lapund, who is the mascot of Turkusec, where I'm also participating, which is if you're not in the city secs, please do go into them, because it's the same as this community here. It's one of the most welcoming communities I have ever met. But yeah, machine learning, some call AI. It's not the same term, because they're slightly different. Machine learning is basically the ability of an algorithm to kind of learn when given data points. So in theory, it gets more accurate as it gets more data. And there are several ways of getting into this, because it was the hype term a few years ago. Machine learning, data scientists, machine learning engineers. Go in this, there's a lot of work to be done. So a lot of people did. One option, and there is no, first I had the 1, 2, 3, and then I realized this would imply there is a better way and a worse way. It depends on the expertise of the person and the needs. But one is the way I did. So you have a lot of people with PhDs, because they use these models often in their research, and then they know how to do these models, and they know how to do analytics. And because university careers are not known to be lucrative, they find out that there is this industry where they're paid to do this, instead of them having to hunt for the money to do this. So machine learning is the very common way to do that. So they have a lot of experience in analyzing data, in building models and making sense of it, but they don't have an IT background. So DevOps, version control, testing, security, they might know it. A lot of people pick it up as they go along. But this is one of the reasons why in the industry there is a bit of a problem with, we have a lot of proof of concepts that kind of never end up in actual use. According to Gartner, it's like 15% of AI projects are actually then into use. And then also we have companies which have a varying amount of proof of concept built models that do something. They're all built with different technological solutions because they were built by different people in research projects, but there's no unified structure to them. There is no platform with unified way of doing. There is no guidebook or playbook of this is how we build these solutions. So they're quite hard to maintain sometimes, which is often when, like Solita comes and we help them figure out how to go from this proof of concept trap into doing it in a way that it is maintainable and it is easy to develop and the company knows what their models are doing and when they need to be retrained and all that. But that's the one, and yeah. The second option, which is we're seeing more and more, is that the people have started like either in IT or they studied machine learning in university, and then they get also some of the computer science into it. So DevOps practices, security basics. So more and more of that. And then we have the self-taught. There were a few years when I kept running into these, come study at us. We're going to teach you to be a machine learning professional in 6 months. And yeah, maybe, but there's a lot to unpack. So 6 months is not a lot of time, but it's a varied bunch. So if you have people who are machine learning engineers or data scientists, and you're responsible for the security and IT, it could be worthwhile to go and talk with them and like what's their background, and then you can kind of get a grasp of do they have any gaps that need to be supported. Because the security in these AI, machine learning or generative AI projects is often handled by machine learning people. Because like when you develop something in IT, it's usually in conjunction with the IT, but machine learning is different. For one, it is something like there's this idea about it that it is something separate. So the standard practices sometimes don't apply for machine learning. Often the machine learning scientists and engineers, they are put together with the business people because we need that expertise to build good machine learning solutions or generative AI solutions. We need that expertise. But they're not the IT people, and they're not the security people. Neither are we, often. Machine learning, it's such a vastly and quickly developing industry. We kind of have to choose what we get expertise on. So we're not experts on security. We're not experts in the infra of cloud or on premises. So don't leave us alone to, just build in production systems. And if you're doing these in your company, find out where your DevOps people are, where your security people are, and please put them in the team with the machine learning people so they support each other to build better solutions. And this is basically, in a nutshell, that's my presentation, but I will go into more detail as we go, but repetition is the mother of all learning, and this is important. Now we have generative AI, which can be as simple as an API call. No need for the machine learning people. They may not know the DevOps, They may not know the security, so why do we need them? Well, machine learning is, and especially generative AI, it's kind of this... Well, there are people who describe it as a giant backdoor. It can do surprising things. And you don't get an error message when it does something odd. This morning when I was coming to Helsinki by train, I ran across this court decision in Canada, which is not European Union, but is still interesting, where a customer had gotten into, had searched for information on claiming for bereavement. So he was flying to a funeral of a relative, and he had checked by a chatbot, when do I apply for the compensation? Had gotten advice, and then tried to implement it, and was told that no, this advice is, no, it doesn't work like that. So they sued the company, Air Canada. And Air Canada's position on this is that the chatbot is a separate legal entity responsible for the content it creates. Yeah, that didn't fly. I see a lot of these cases popping up in different geographical areas. I'm quite happy with the court's decision that no, it is not the responsibility of the customer to fact-check the output from a different part of the website. So, yeah, to be 100% sure, I'm not sure that would be preventable, but possibly. But please collect the team who know what can happen. So this year, with hype around generative AI, this is kind of what I've been doing this year, talking to my colleagues and trying to find out, what are the risks, the attacks, how it fails, and trying to find what's the terminology. And you see a lot of hype terminology there. Generative AI, MLSecOps, DevOps, Devsecops. MLOps, then there's, of course, because there are large language models often in generative AI, so you have LLMOps. You have platform engineering. No, basics is not, that's not the hype term, but what I've done a lot this year is try to figure out where's the necessary expertise? What's behind the terminology? How do we build the team? What is the expertise we need to be in a better place with these? And what can go wrong? And of course, yeah, luck. No matter how good people are, luck always plays a part in it. So, briefly about generative AI. It is more and more in a lot of solutions we use. You can generate images, you can generate text, and it has this kind of human-like interaction. And it generates stuff. I generated most of the images. I played around with DALL-E 2 and DALL-E 3, which was a lot of fun. I have included a lot of my prompts in these slides. There's a vast difference between the models. This is developing really fast. So DALL-E 2 does not get or from me anyway, didn't understand terms like generosity or thankfulness or these ideas, whereas DALL-E 3 could. So there's a big difference when these models develop, and this is moving really fast. It adapts, it learns and evolves in response to data, and it's quite versatile, so you can do a lot of things with it. I can see how having these solutions can help me create slide sets like this. Of course, only the images are generated with this. The text is my own, in typos and all. But they can be very useful, very valuable, and make you work better, faster, do useful stuff. But it's also this. There's a nightshade that is a tool because some people are unhappy with their art being scraped off the internet to be used to train these foundation models. So Nightshade lets you poison your images. So if they are then scraped and used to train these models, it breaks the model. It makes the predictions and the outcomes worse. So that's gaining popularity. ChatGPT has leaked users' conversation histories. You can pretty easily get past the guardrails, because like for these to be safe, you build guidelines and guardrails that they need to follow when they're producing the output, but you can get around these. Companies have realized that their workers want their work to be easier, and so they put all kinds of content into these solutions. So, and that can be prompted out of it. So there's some secrets that have leaked, of course. Then users will always be users. There was a lawyer, like this was already a year ago, who prepared a legal brief using generative AI. And he went so far in the due diligence of asking the generative AI of, are you sure these legal precedents are actually real? And was convinced by the veracity of course they are, that, well, they weren't, of course, because they can produce very real-sounding examples that are still false. And because it's trained on internet data, like there's no biased information on the internet. You know, it's fully like all kosher. So, but yeah, it's very biased. And it's been shown that it's more biased easily. Yeah, there's a lot of things which makes my life interesting. But basically, it is still, it's based on technology, and some of the solutions were developed like decades ago, or like the algorithms and the ideas. But they work now because we have a lot more compute and a lot more data. So they've become viable. But the technology, or large parts of it, are not that new. And already like in the 2000s, the definition of what artificial intelligence is, which was developed already in like 96 in the Dartmouth conference, was fulfilled. So we had computer vision and natural language capabilities. And with generative AI, these separate fields like language and audio and images, they're all combining to these big multimodal foundation models, which means that the large number of people working in these kind of separate fields are now all working together on these foundation models, which can handle all kinds of data. So the speed of evolution is massive. But basically, generative AI is this simple. You have data set, which in foundation models is large parts of the internet. Every bit of data they could scrape. Then you have the foundation model, but it has no context, and it has no new points of information, so those need to be added. If you want to use it, and you want it to know something about your company, like maybe have something that looks at all the knowledge base you have accumulated, then you need to either fine-tune it, which is you train it with your data. But what is more standard operating practices is RAG, which is retrieval augmented generation, which basically means you first do a search from that knowledge base, you get the best parts that fit the question, and then you feed that and the question to the foundation model to produce the response from basically your data. And then you also see like where the parts of the answer come, so you can go back and fact check it. And this is fairly, at this time, standard operating practices. And then you of course have all the bits built around it to make sure it's monitored, it's logged, there's alerts, and all the things that you need to bring this proof of concept simple thing into something that is actually used by potentially a lot of people. And you can build it on cloud, or you can build it on premise. There's a lot of open models that if you work for an organization that cannot use the models that you can get through an API, there's a lot of models you can build on-prem. It's in a network, always. And it's interacting with the other systems. And basically, the blue box, that's the machine learning part of it. So most of an AI solution is something other than AI. And this is why you need the collaboration. So the large language models, they don't see words. They see numbers. So you feed it sentences, which are broken down into tokens. Then they are embedded into meaning. So like, as a human being, you can say like, what words are related to the word like king? It's a man, it's royal, like this sort of thing. But it doesn't have to be done by hand. It's a machine learning model, which will embed a meaning into all the words. And then it is able to produce very human-like output, even though it still sees just numbers. And then you have the context added to it. But I find it actually quite impressive how good the output is, just like thinking it's just the numbers. And what it produces is the statistical probability of what is the next word. When it's in language, of course, pictures slightly different, but it's still the statistical probability. So it is not an expert on the context. It is not an expert in the content. It is very good at predicting what the next word should be in language, how that works. But it can produce somewhat, well, surprising outcomes. So that's why it needs the guardrails. Because like this is not something we want the company to produce of how you should do. And briefly, because I'm running, I love talking if you don't. Yeah, so adoption is increasing. A lot of companies want to try out. Models, tools, frameworks, something is coming out all the time. All the big cloud players are producing capabilities of using this and utilizing this better and easier. You have also a lot of regulation coming in the European Union. AI Act, AI Liability Data Act. Then you have the cybersecurity part, which is NIS2, DORA. Like there's a lot of regulation coming, which will affect what we do. And then, of course, you have the local laws and industry laws. Like if you're building a solution for medicine, it's going to be the laws are somewhat different. There's also lawsuits around the world. What's the intellectual property aspect? Because it's just scraping the data off the internet. So some of that data or a lot of that data, there's intellectual property attached to it. So how is that handled is going to be very interesting, because what will happen to these models if they cannot scrape that data? And yes, it hallucinates. And the hallucination is basically, it's making stuff up. These are not models that are good at saying, I don't know, maybe because that's not what you find on the internet a lot. Usually you have internets and there's a lot of people who know stuff. So there's not a lot of answers of, well, I don't know. That's not a common response, so they don't know this. And then these are black boxes. Like, these have surprised the people who create them and the researchers who use them several times of why are they able to do this, because we didn't teach them to do this. Until these foundation models, if you trained a large machine learning model, it is like a scalpel. It does the one thing it's supposed to do. It can do it well, but it does the one thing. Now, these are doing more than just the one thing. So, yeah. But they are also used for less good purposes. There's a lot of deep fakes. You can, like, with this data that will go on the internet, you can deep fake me into various situations, or you can use my voice and make a deep fake to try to con others. Like, there's already scams of child's voice being utilized to call the parents and get stuff out. So this is gonna be interesting. Cyber attacks, or you can use this to generate code. A lot of it is buggy and has security problems, but in this use case, it might not matter. So if you can tell this model just by natural language of what you want the code to do when you get the code, you don't have to be an expert. These tools are very easy to use even without that expertise. And they're vulnerable to attack, and some say it is a big backdoor. And they can be attacked. You have the supply chain vulnerabilities. You can poison the data set, or you can poison the model. And basically, the data is internet. So who can produce information to the internet? Basically anyone. So getting this kind of a model to say something specific about a very narrow topic, you don't have to break into anything. You just create content on the internet where the model where the company scrape this data to train these models. And that's the facts they learn. You can, like, the guardrails that are supposed to put around it, they're quite easily evadable, and you can use prompt injection to circumvent the safety and security. Oracle attacks are, I think, more common for machine learning, but you can try to figure out why the model works, and this is some of the headlines have been discovered this way, that we're just prompting the model and see what kind of output it produces. Privacy attacks, well, this is how the companies have kind of been found out of how much private data they have used. And then, of course, if you have the solution that utilizes this, and it's an OpenAI model or something, every prompt costs something. Every result the model produces costs something. So it's fairly easy to do a DDoS attack. You just prompt the model. And at some point, you're going to run into the payment constraints, and the solution doesn't work anymore. And yeah, it hallucinates. So at this time, one way of thinking at it is it's kind of like a 5-year-old or a 6-year-old, but it's a child. It will say stuff, and it will be very sure it's accurate, but it is a child. It makes things up. So use it for things where you can fact-check the results. So that's quite important. And we talk of the hallucinations, but it is not an unproblematic term, because they're not conscious, and we cannot think of them kind of as having consciousness. They don't have intent. They're just predicting the next word. What's the most likely next word? And I have these, like, I had so much fun generating the images, by the way. I compared the DALL-E 2 and DALL-E 3. And DALL-E 2 had no problem imitating Banksy. I don't know how well, but... And you know, the text in images in DALL-E 2 is not that good. DALL-E 3 there's more guardrails, so it refuses to imitate live artists. It says it won't, and then it regenerates the prompt to do another picture of kind of what it thinks that you thought, except it's not thinking. Yeah. User consciousness is very much needed. So if you're building these solutions, do also educate your users on how it works, when it works, know if it doesn't. And the conversation we've had a lot is, will they follow these instructions? Humans are known of trying stuff out just for the fun of trying stuff out. And you have the car dealership last Christmas where that gave this powered by ChatGPT chatbot on their website, which was discovered and then was found out that, yeah, you can use ChatGPT for free. You just use the chatbot of this company to do it, and people did all sorts of things. And we have results like this. Did you know we're all invaded by Sweden? This was a colleague of mine that wanted to generate an image of Sweden and all the sports places in Sweden. And this is the output. So if you use this kind of at this point in time, it's quite important that you use it for situations where you can fact check it. For pretty much everyone living in this part of the world, it's fairly simple to know that this is not accurate. But this image generated on the other side of the world, well, this is the magical country of Scandinavia or something. So you need that capability of fact-checking the results. Now going to the security. This was my first attempt of how these terms that I will briefly go through, how they interact and what's the content. But the main idea is that we know how to do this already, a lot of it. We know how to do this. But it isn't all hands on deck. It's a team sport. So starting with basics, when going to production, latest. Pilot is when you kind of try and see if this works, can this be done? So a lot of the security guardrails and DevOps practices are not built at that point because you want to save money, because if it doesn't work at all, why would you make it safe? But then also there are situations where it's already in production and by then the company thinks it's too late because it's expensive to build them after the fact. So backups, testing, access control, updates, firewalls, encryption, like these are basic things, but they're not always done. And the thing is that machine learning is often done with production data. And often the roles, we either have no access or we have admin access. So the basics are needed. Do check with your machine learning people, do they know how to do them? If not, give them team members that can. And then you have the platform engineering and Devsecops, and because it's a generative AI, I use generative AI to come with this, or my colleagues. I did these push-ups with my colleagues, and basically platform engineering is you have the template, Terraform template, or like ARM template that is scalable, automated infrastructure that is repeatable, which is how you can avoid the problem of having each solution built differently. And then you have the Devsecops, which is integrating the security and compliance measures into the workflow, instead of having that be the last step before it goes into production. That it is in each step, that there's someone in the team who knows the security of it and keeps that in mind all the time. So stop reinventing the wheel, and please help your machine learning people that they don't have to reinvent the wheel every time, and do apply DevSecOps culture. Have people who are security aware and are interested in it, and the reason we need them is basically because of this. So the platform to do these solutions is then set up and ready to go. We don't have to learn them. We can focus on, like, if these are done, I am very happy a machine learning person. I don't have to do these every time. And it can support wise choices and prevent the worst ones. To do platform engineering, it's like you can build those policies of what you really shouldn't do, because we're also asked to do the APIs a lot of the time, to configure them in the cloud environments. And it can be the first project we've worked with that cloud, or the second. And so, yeah, utilize these. And if you have people in your company who do platform engineering, get them talking with the machine learning people so they know what they need to take into consideration that is specific for machine learning. And then you have the Devsecops, you have the tools and the ways of doing things. It really helps. And so basically looking at this, those two help with a lot of things around the blue box. Then you have MLOps, which is like DevOps with ML. And now you have the new term, because this industry really loves making up new terminology all the time. It's fun. So you have the LLMOps, which you have the basics. You have version control, testing, monitoring, logging, alerting, processes. And these are needed. And these are missing in a lot of places because they're not always taken for sure or known how to do. And these are things that are usually built when taking the solutions into the production. So not in the first versions, and sometimes these are left not done. And the newest kid on the terminology block is the MLSecOps, which looks at the security of machine learning. So taking the idea of trusted AI in what model you choose. Do you check it for explainability, bias mitigation, fairness? Do you assess the supply chain at all for vulnerabilities? You need to trace the origin, lineage, and evolution of the model, which is quite hard with these new foundation models because they don't really make them public and they change them without telling you or asking you, and they just change things. And you think of the governance and risk and compliance, and please be risk aware, assess your risks and mitigate and manage. And then also utilize adversarial machine learning. So try and break it and see if it breaks. And then if it breaks, fix it. The solid threat matrix that me and my colleagues looked at last summer was based on Wasp, Gartner, and other known sources. But the top 10 are some of the things we have already gone through, like basic security practices, security by design, being aware, authorize with minimum privileges, because basically you can connect a generative AI model to your database and have it just query stuff. In which case the prompt injection and the hacking is, you ask please. And it can do stuff it shouldn't. Have a human in the loop, at least at this point, is safest with these solutions, so you don't end up with like Air Canada. So having that GenAI solution helping your help desk help the customers is already a safer solution than handing it over to the end users to do whatever they want with it. Validate, test, verify all the time. Minimize any personal data. Teach your employees that they should not put personal data into these models, especially if you use the models like OpenAI, which is then transported to the US and used for retraining, because that model that you feed to these models, if it's not secured, is then fed to the next evolution of these models, and it can, in theory, be prompted out of it. Design for failures and look at the regulation. And this needs to be done throughout the life cycle of these solutions. So when you start to build it, what does it need to do? Should it be done? Is this a good idea? Like putting a way to utilize ChatGPT on your front page so everyone who is interested in using ChatGPT can use that instead of paying for the model themselves? Maybe not the best idea. What are the risks? Who will use it and why? Because that's also one reason that machine learning sometimes or the projects fail, because the people don't want to use it or don't know how to use it. So do involve the end users fairly early on. Then you build the pilot. Can it be done? And already start thinking about the risks and their mitigation, how to secure it, how to keep it safe. And then think also how it will be used in practice, because users do not always follow what we tell them they should do or shouldn't do. So how do you take that into consideration? And then when it's put into production for a large group of people to use, kind of make sure you know what it's doing, and it's doing the things it's supposed to do and something else. You can use machine learning for this, and it is used, but do have a human every now and then kind of checking what is going into the model, what is coming out. Because if you don't follow these, if you don't build these structures to see what's the input, what's the output, you don't know unless someone tells you that, oh, this is what it gave out. And then already in the ideation stage of a machine learning product, you should already be thinking of the funeral of it. Because at some point, the technology is growing and developing so fast. Under what conditions is this solution taken offline and needs to be replaced? So start thinking about it, because it's going to happen. And with the technology changing so fast, it can be faster than you think. But this can be just me. I like doing work, I like being busy, and this kind of lets me do that. But also the technology is developing so fast at the moment that things you couldn't do with DALL-E 2, you can with DALL-E 3. And then, of course, swapping the model is fairly simple. So with GenAI, it might not necessarily be the end of the solution, but it can be when you need to swap the models for the next better working foundation model. So, sorry. I tried to remove most of my animations, but seem to have missed one. So, a lot of terms, in this time of talking with a lot of beautiful colleagues of mine who answer all my questions so very patiently and explain stuff to me, I kind of figure out, it is this puzzle. And it is a puzzle where companies who want to build this stuff, they have the pieces. It's just about bringing them together. It's about connecting your machine learning people, whether you're owner consultants, with your IT people, with the developers, with the security people. Not just having them talk with the business, but bringing all of that into a team. So no one knows it all. And with this growing so fast, changing so fast, it's quite hard to stay up to speed, because new ways of doing it come almost every day. Yeah, so if you have a team of one and security is their responsibility, unicorns are mythical for a reason. When I started this transition to machine learning, I bought this unicorn stuffed animal that I put on my backpack as this way of, this is what I want to be. I want to be this mythical unicorn. Now it's there as a warning example. There's no such thing. So I don't have to know everything. And if you expect us to be these unicorns, well, I don't know if this joke makes sense to everyone, but basically the horn growing on our foreheads, it's a horn on our foreheads, it might not be that of the unicorn horn. But we might get slightly, well, it's impossible. So please, build a team. Build these people with different expertise and bring them together to build these solutions. All right, thank you.